I want to show you two ways that we can factor trinomials where the lead coefficient is not equal to 1. Those are trinomials that might look like 2x squared minus 3x minus 20. This is where this lead coefficient here is something other than 1. So the first thing that we're going to do, there's two methods to do this. The first one is factoring by grouping. So I'll show you that one first. We're going to start by multiplying the first term and the last term. So 2 times negative 20. That'll give us negative 40. And we want to make a list of numbers that multiply to negative 40. And I'm not too worried about the signs because we know if one of them is positive and one of them is negative, we'll get the negative 40. So we got 1 times 40, 2 times 20, 4 times 10, and 5 times 8. And we notice that if I have a positive 5 and a negative 8, and I add those together, I'll be able to get this middle term here, negative 3x. So I'm going to rewrite this trinomial up here as a polynomial with 4 terms, but instead of writing minus 3x, I'm going to write it as minus 8x plus 5x. And then I'm going to factor this by grouping. So I'm going to say, what is it that I could take out of these two? And we notice I could take out a 2x, leaving an x minus 4. And what could I take out of these two? And that would be a 5, leaving x minus 4. And then I notice that I have this common binomial term, so I'll pull that out in front, leaving me with 2x plus 5. And I've factored my polynomial. And you can check it by multiplying it out. X times 2x is 2x squared. X times 5 is 5x. Minus 4 times 2 is minus 8x. And then minus 20. And we know that that adds to the negative 3x that we began with. So this is factoring by grouping. You're going to first multiply the first times the last. You're going to find factors that multiply times the first times the last that will add to the middle term. You can stretch out your middle term. And just a side note, it would not have mattered if I would have put 5x first and minus 8x second. We would still get the same result. And then we factor by grouping. So I'd like to do the same problem using a different method. This method is sometimes called voodoo method by my students because it does seem a little strange. So we'll start with that same polynomial. And this will start exactly the same way. We'll multiply 2 times negative 20, and we'll get negative 40. That will give us the same two numbers that we had before, positive 5 and negative 8. And now we're going to do something different. We're going to take this lead coefficient of 2, and once we've decided on these two numbers here, positive 5 and negative 8, we're going to divide each of these by that lead coefficient 2, and then we're going to reduce what we have. So that's going to give us positive 5 over 2, because it's already reduced, and negative 4 over 1. And then we're going to move these denominators up, and we're going to get 2x plus 5 and x minus 4, which is what we got last time. And we've already checked, it does multiply out to the original polynomial. So just to give you one more example of a polynomial, let's start with 6x squared minus 11x minus 10. And let's go ahead and do the voodoo method since that's the one that seems a little strange to people. If we multiply 6 times negative 10, we're going to get negative 60. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. And we're looking for two numbers in this list that will add to negative 11. So we notice that if I choose positive 4 and negative 15, these two numbers will add to negative 11 and multiply to negative 60. I'm going to divide these each by the number 6, leaving me with positive 2/3 and negative 5/2. And then I will move these two denominators up, giving me 3x plus 2 and 2x minus 5. So students tend to like this method better because it's a little quicker. Does not matter to me how you're going to factor these as long as you're able to factor a trinomial where a does not equal 1.